On 20 December 2021, an eruption began on Hunga Tonga, a submarine volcano in the Tongan archipelago in the southern Pacific Ocean. The eruption reached a very large and powerful climax nearly 4 weeks later, on 15 January 2022. Hunga Haʻapai is 65 kilometers north of Tongatapu, the country's main island, and is part of the highly active Tonga Kermadec Islands volcanic arc, a subduction zone extending from New Zealand north-northeast to Fiji. Submarine volcanoes are underwater vents or fissures on the Earth's surface from which magma can erupt. Many submarine volcanoes are located near areas of tectonic plate formation, known as mid-ocean ridges. The volcanoes at mid-ocean ridges alone are estimated to account for 75% of the magma output on Earth. The eruption caused tsunamis in Tonga, Fiji, American Samoa, Vanuatu, and along the Pacific Rim, including damaging tsunamis in New Zealand, Japan, the United States, the Russian Far East, Chile, and Peru. At least 4 people were killed, some were injured, and some remain possibly missing in Tonga from tsunami waves up to 15 meters high. 2 people drowned in Peru when a 2 meters wave struck the coast. Preliminary data indicate that the event was probably the largest volcanic eruption in the 21st century, and the largest recorded since the 1991 eruption of Mount Pinatubo. NASA determined that the eruption was hundreds of times more powerful than the atomic bomb dropped on Hiroshima. After staying relatively inactive since 2014, the Hunga Haʻapai volcano erupted on 20 December 2021, sending particulates into the stratosphere. A large plume of ash was visible from Nuku'alofa, the capital city of Tonga, about 70 kilometers from the volcano. The Volcanic Ash Advisory Center in Wellington, New Zealand, issued an advisory notice to airlines. This initial eruption ended at 2 o'clock on 21 December 2021. Volcanic activity continued, and on 25 December 2021, the island had increased in size on satellite imagery. As activity on the island decreased, it was declared dormant by the Tonga Geological Services on 11 January 2022. A large eruption commenced on 14 January 2022 at 4:20 local time, sending clouds of ash 20 kilometers into the atmosphere. The government of Tonga issued a tsunami warning to residents, and waves of 30 centimeters were observed in Nuku'alofa. Later in the afternoon, Tongan geologists near the volcano observed explosions and a 5 kilometers white ash column between 1700 hours and 1830 local time. A much larger eruption started the following day, 15 January 2022, at 1714 local time, 4:14 and 45 seconds UTC, 15 January. The eruption column from this eruption rose 58 kilometers into the mesosphere. The VOC again issued an advisory notice to airlines. Ash from the eruption made landfall on the main island of Tongatapu, blotting out the sun. Loud explosions were heard 65 kilometers away in Nuku'alofa, and small stones and ash rained down from the sky. Many residents in Tonga were stuck in traffic whilst attempting to flee to higher ground. The explosion was heard in Samoa, roughly 840 kilometers away before the sound traveled to more distant countries. Residents in Fiji, more than 700 kilometers away, described the sounds of thunder, while the thump of the eruption was also reported in Niue and Vanuatu. Tremors and shaking buildings were reported by residents in southwestern Niue, around Alofi and Avatel. The United States Geological Survey estimated the eruption at a surface wave magnitude of 5.8. The eruption was heard more than 2,000 kilometers away in New Zealand, where the sound arrived 2 hours later. A series of bangs were heard around 3:30 a.m. local time in and around Anchorage, Alaska, approximately 9,700 kilometers away from the volcano, lasting about 30 minutes. Low-frequency noise persisted for approximately 2 hours. Booms were heard as far away as Yukon in Canada. The volcanic explosion caused atmospheric shockwaves to propagate around the globe. Satellites visually captured shockwaves propagating across the Pacific Ocean, and a very wide eruption column. The pressure wave was measured by weather stations in many locations, including New Zealand to a maximum amplitude of about 7 pa, and Australia to 6.9 pa at Lord Howe Island, and 3.3 pa at Perth. Even in Europe, a pressure fluctuation of 2.5 pa was measured in Switzerland, and just over 2 pa when it reached the United Kingdom. Shock waves were reported as having gone around the Earth as many as 4 times in Japan and Utah, and at least twice at the Blue Hill Meteorological Observatory in Massachusetts. The pressure shock wave was also observed in Chennai, India, which is 12,000 kilometers from the eruption site. Intense lightning activity was recorded during the eruption phase. The Vasula National Lightning Detection Network detected lightning in the form of radio waves. Several hundred to 1,000 flashes of lightning were recorded by the system during the 2 weeks before the eruption. From 14 to 15 January 2022, tens of thousands of lightning flashes occurred. Between 5 o'clock and 6 o'clock UTC on 15 January 2022, 200,000 flashes were recorded. Preliminary observations showed that the eruption column ejected a large amount of volcanic material into the stratosphere, leading to speculation that it would cause a temporary climate cooling effect. Later calculations showed it injected an estimated 400,000 tons of sulfur dioxide into the stratosphere, and was unlikely to have any global cooling effect. Despite this, the eruption can have a cooling effect in the southern hemisphere, causing slight cooling of winters and spectacular sunsets. People living in the southern hemisphere can expect purple sunsets for a few months after the eruption. The cooling effect of 0.10.5 degrees centigrade, 0.18-0.90 degrees Fahrenheit, may last until spring, September-November 2022. The eruption was described as a once-in-a-thousand-year event for the Hunga caldera, and the event could rank as high as 5 on the Volcanic Explosivity Index. A March 2022 study in the journal Earthquake Research Advances concluded that this eruption resulted in the formation or alteration of the Hunga Tonga Hunga Haʻapai caldera. With a plume height rising 58 kilometers into the atmosphere, this eruption is thought to be more powerful than the 180C Haʻapai eruption. The eruption occurred within a span of 12 hours, releasing 1.9 km3 of ejecta, with an estimated mass of 2,900 teragram. The eruption correlated to a VA of 5.6. A research paper published by the American Geophysical Union in April 2022 indicated that the eruption is the largest ever observed with modern instrumentation, and estimated the VA to be 6. Tsunamis are most frequently caused by earthquakes, while those caused by volcanic eruptions are rare. Fewer than 100 volcanic tsunamis were recorded in the prior 2 centuries. According to an official at GNS Science, the suspected cause of the tsunami was an undersea eruption that destroyed part of the island on 14 January. This allowed seawater to fill the volcanic vent, causing another undersea explosion the next day. The explosion was so huge that it penetrated through the sea and triggered the tsunami. Tsunami forecast models and alert systems which were intended to work for earthquake-generated tsunamis failed to consider the effects of the shock waves on the tsunami, as it radiated outwards. Shock waves from the eruption caused abnormally high waves along the coast of Peru and Japan. The tsunami waves also struck the coast earlier than forecasted. As a result of the eruption, a 1.2 meters tsunami struck the Tongan capital Nuku'alofa. Tide gauges in the city recorded waves 1.52 meters in height. Videos posted on the internet showed a series of waves hitting the shore and homes, sweeping away debris. Other videos show ashfall and a cloud of ash obscuring the sun. According to a resident in the Tongan capital, a series of initial smaller explosions was heard. It was followed by a tsunami approximately 15 minutes later. The first wave was said to be the largest. A long white wave was observed out at sea approaching the coast. 3 waves reportedly struck the coast. In the wake of the tsunami, King Tupuvai was evacuated from the royal palace, and traffic jams formed as locals fled inland or to higher ground. Based on an unofficial first-hand account of the tsunami in Tonga, Risklayer developed a tsunami inundation map. From the map, a tsunami with a height of 15 meters, 49 feet, or greater, may have struck the west coast of the island of Tongatapu, where heavy damage was inflicted. The Tongan government, on 18 January 2022, confirmed waves of up to 15 meters, 49 feet, struck the west coast of Tongatapu, Ua, and Haʻapai Islands. In Fiji, a tidal gauge in Suva recorded a wave measuring 20 centimeters at 1740 local time. Some tsunami activity was also reported in the Lau Islands. The islands of Mos, Mola, Kadavu, and Tavuni were struck by low-level tsunamis that triggered flooding. In American Samoa, a tsunami measuring 61 centimeters was recorded by tide gauges. Niue, where residents evacuated coastal areas, reported no tsunami, despite tremors in the island's close proximity to Tonga. Tsunami waves of 2.5 meters were observed on several islands in Vanuatu. The Vanuatu Meteorology and Geohazards Department said tsunami activity was expected to persist for the night of 15 January 2022. Waves up to 0.8 meters in height were recorded in Hanalei, Hawaii. The combination of a cyclone surge from Cyclone Cody and the tsunami caused extensive damage at a marina in Tuchakaka in New Zealand. The waves pulled boats away from their moorings, taking some out into the bay and smashing some together, as well as damaging the structures at the marina. About 8 to 10 boats were completely sunken, with the total damage estimated to be worth millions of dollars. According to Hauraki Gulf Weather, the tsunami struck on 16 January 2022 between 1:05 and 1:10 local time on Great Barrier Island, with a height of 1.33 meters. The tsunami caused flooding at Mahinepu Bay, where a campsite was located. All 50 individuals at the site were safe. A group of people fishing in Hokianga Harbor had to run for their lives to escape the waves, and reported having to drive through water over 1 meter deep. Unusual waves were recorded in Port Taranaki in New Plymouth. They lasted 24 hours, with the largest having a peak-to-peak height of 1 meter at 8:30 local time. There were no casualties reported in New Zealand. In Australia, the Bureau of Meteorology said tsunami waves were observed throughout Saturday night on the shores along the east coast of Australia. Maximum tsunami waves of 1.27 meters were recorded at Norfolk Island, 1.10 meters at Lord Howe Island, 0.82 meters at the Gold Coast, Queensland, 0.77 meters at Twofold Bay, New South Wales, and 0.50 meters at Hobart, Tasmania. The presence of water can greatly alter the characteristics of a volcanic eruption and the explosions of underwater volcanoes in comparison to those on land. For instance, water causes magma to cool and solidify much more quickly than in a terrestrial eruption, often turning it into the volcanic glass. The shapes and textures of lava formed by submarine volcanoes are different from lava erupted on land. Upon contact with water, a solid crust forms around the lava. Advancing lava flows into this crust, forming what is known as pelalava. Below ocean depths of about 2,200 meters, where the pressure exceeds the critical pressure of water, 22.06 MPa or about 218 atmospheres for pure water, it can no longer boil, it becomes a supercritical fluid. Without boiling sounds, deep-sea volcanoes can be difficult to detect at great distances using hydrophones. The critical temperature and pressure increase in solutions of salts, which are normally present in the seawater. The composition of aqueous solution in the vicinity of hot basalt and circulating within the conduits of hot rocks is expected to differ from that of bulk water. One estimation is that the critical point is 407 degrees centigrade and 29.9 Pa, while the solution composition corresponds to that of approximately 3.2% of NaCl. Scientists still have much to learn about the location and activity of underwater volcanoes. In the first 2 decades of this century, NOAA's Office of Ocean Exploration has funded exploration of submarine volcanoes, with the Ring of Fire missions to the Mariana Arc and the Pacific Ocean being particularly notable. Using remote-operated vehicles, scientists studied underwater eruptions, haunts of molten sulfur, black smoker chimneys, and even marine life adapted to this deep, hot environment. Research from the Rob Kaiko off the coast of Hawaii has suggested that Pahoho lava flows occur underwater, and the degree of the submarine terrain slope and rate of lava supply determine the shape of the resulting lobes. In August 2019, news media reported a large pumice raft floating in the South Pacific between Fiji and Tonga. Subsequent scientific investigations revealed the pumice raft originated from the eruption of a nearby submarine volcano, which was directly observed as a volcanic plume in satellite images. This discovery will help scientists better predict the precursors of a submarine eruption, such as low-frequency earthquakes or hydrophone data, using machine learning.